Hello everyone, welcome to The Learning Notebook. Today we are continuing our series, Computer Fundamentals, and this is Lesson 7. In this lesson, we will learn about the memory and storage devices. But before we begin, you can check out other videos of this series from the Computer Fundamentals for Beginners playlist. Now, let's get started.
So, what's on the agenda today? We're going to cover four main things: semiconductor, or main memory, magnetic memory, optical memory, and then we'll wrap things up with a quick recap quiz to test your brand new knowledge. Okay, let's start with the basics. What actually are memory and storage devices? Well, they're the absolute unsung heroes of any computer system. Literally, without them, your computer couldn't hold on to any data, instructions, or information. It'd just be a shiny metal box. We generally group these devices based on four main things: the underlying technology they use, how fast they are, their storage capacity, and their permanence. Permanence basically just means, does it keep my data safe when the power gets turned off? Based on those features, we've got the three major types we're diving into today.
Let's jump right into our first major category, Section 1, Semiconductor or Main Memory.
All right, so semiconductor memory is basically your computer's active thinking space. It's built using integrated circuits and semiconductor materials. A really great way to think about it is like your physical desk. Because your CPU needs to grab this data instantly while it's working, it is insanely fast. But, just like a physical desk, it only has so much room. It has a limited storage capacity, and it's actually pretty expensive to make compared to secondary memory. Oh, and here's the absolutely crucial part. Much of it is volatile. That means if the power suddenly goes out, your desk gets completely wiped clean, and poof, that active data is gone.
Now, inside this semiconductor family, we've got two main stars that you've probably heard of: RAM and ROM. RAM, which stands for Random Access Memory, is the volatile one. It forgets everything the second the power drops. A perfect example is the memory your computer uses right now to run your active applications. On the flip side, we have ROM, read-only memory. This guy is non-volatile, so it remembers things permanently. A great example of ROM in action is storing the BIOS instructions. That's the essential code that tells your machine exactly how to boot up when you first hit the power button.
All right, moving on from the main memory, let's talk about where we put things for the long haul. Section 2, Magnetic Memory.
So, magnetic memory gets its name because it literally stores your data using tiny magnetic patterns on a surface. If your main memory is that active desk we just talked about, magnetic memory is like a massive metal filing cabinet sitting over in the corner of the room. It gives you huge storage capacity, and it's incredibly cost-effective. Sure, it takes a little longer for the computer to dig a file out of that cabinet compared to just grabbing it right off the desk, but because it holds so much data so cheaply, it's absolutely the go-to for your backups and long-term storage.
So what does magnetic memory actually look like in the real world? Well, the biggest one is the HDD, or hard disk drive. That's probably where your operating system and all your personal files live right now. Next up is magnetic tape. I know it sounds super old school, but believe it or not, it's still heavily used today for massive, large-scale data backups because it can safely hold an immense amount of data. And finally, we can't forget the classic floppy disk. It's another form of magnetic memory, and yep, it's the granddaddy that inspired our modern save icon.
Let's roll right into the third and final category in our storage lineup, Section 3, Optical Memory. Optical memory is fascinating because, unlike the others, it uses light to manage your data. Specifically, it relies on laser technology to read and write information onto reflective surfaces, like disks. It's a fantastic, highly portable storage medium, boasts a really low cost, and generally gives you a solid, moderate amount of storage. Plus, a huge bonus here, it's incredibly resistant to magnetic damage. You literally don't have to stress about a stray magnet accidentally wiping out all your saved files. You definitely recognize the everyday examples of this one. We've got the CD, or compact disc, which totally revolutionized how we store music. Then came the DVD, or digital versatile disc, which stepped it up and gave us enough space for full-length movies and big software packages. And finally, the Blu-ray disc. This one uses a super precise blue laser, which lets it pack massive amounts of high-definition data onto a single standard-sized disc. To bring this all together, why should we care about these three types of devices? Well, memory and storage literally form the backbone of any computer system. They're what allow the actual processing and execution of data to happen. They give you a permanent home for your critical info, and they boost your system's overall performance, so the CPU isn't just sitting there waiting for data to arrive. They also make crucial backups and recovery possible. Essentially, semiconductor memory gives you that blistering speed, magnetic memory provides the bulk storage, and optical memory gives you portability.
You really need all three working together for a computer to function efficiently. Okay, time for the fun part. Let's see how much of this stuck today. Welcome to Section 4, our quick recap quiz. I'm going to read a question and the options, give you a brief second to think, and then we'll reveal the answer. Let's jump in.
All right, question 1. Semiconductor memory is mainly used as A. Secondary storage, B. Main memory, C. Optical storage, D. External storage. Think about what the CPU needs direct access to.
And the correct answer is B, main memory. Remember, semiconductor memory like RAM is built with integrated circuits to act as the super fast primary workspace for the CPU. Moving right along to question 2. Magnetic memory stores data using A. Light, B. Electrical signals, C. Magnetic fields, D. Heat. The clue is definitely in the name for this one.
The correct answer is C, magnetic fields. Devices like hard disk drives use tiny patterns on a magnetic surface to lock in your files securely for the long haul.
Awesome. Let's hit question 3. Optical storage is A. Magnetic, B. Electronic, C. Laser-based, D. CPU-based. Think about how a CD or DVD actually works. Got your guess? The correct answer is C, laser-based. Optical memory uses highly focused laser beams bouncing off a reflective surface to read and write all that data. Let's try a real-world scenario for question 4. A student stores movie files on DVD. This is A. Semiconductor storage, B. Magnetic storage, C. Optical storage, D. Primary memory.
And the answer is C, optical storage. DVDs, just like CDs and Blu-rays, are classic, everyday examples of optical disc technology. All right, final question. Question 5. Which memory is closest to CPU? A. Magnetic memory, B. Optical memory, C. Semiconductor memory, D. Pen drive. Which one has to feed the processor at lightning speed?
The correct answer is C, semiconductor memory. Because the CPU accesses it directly for active processing, it sits functionally closest to the actual brain of the computer. Great job if you nailed those!
Next time you save a document, think about the invisible journey your data is taking, from the lightning-fast RAM desk right into the magnetic filing cabinet. So that was it for today's lesson. I hope you found this class useful. Don't forget to like, share, and subscribe for upcoming lessons in our Computer Fundamentals series. In the next class, we will study memory hierarchy. Until then, stay tuned, stay healthy, and happy studying. Thank you for watching, and I'll see you in the next lesson.